So we spoke about how you can declare single value reference type attributes like a spouse of a person or trainer of a member. But now let's talk about some multi-valued reference attributes, reference type attributes using array. For example, we have the point array over here. So the point, assuming that it's a class that we already declared, and then we can have point collector. So this part of the lecture assumes you actually completed the reading already for the written notes. Let me go there quickly. So remember, this is a written note you are assigned to read already last week in both the lecture and also in the tutorial video. It's really important for you to complete this. So what I would do is, I'm not going to really trace about the add points, the mutator in detail. I'll just visualize that quickly for you. And then maybe I will trace the accessor get points in Trojan number 1 accessor in detail together with you, right? But the written notes, that's something you must complete the reading yourself. Otherwise, it would be difficult for you to follow the lecture, all right? Okay, let me go back to this slide here. Let me start with the point collector, assuming that we already declare points with x and y coordinates. So we actually got two attributes over here. Just for saving the space on the slides, I simply declared it in one line, but you should have split them into 2 lines. So we got points array. So every index of this particular array is going to store an address of the point objects. It's very similar to the facilities array in the tutorial videos that we spoke about in week number 8. Okay. And also we got some private integer NOP, the counter. So we'll just record how many points there are actually for that you have added so far into the array. And if you record the tutorial videos, there are 2 purposes for this counter over here. Number 1 is going to tell you how many points there are. How many points have been added to the points array. Purpose number 1, and purpose number 2. NOP also indicates about the index for the next point objects to be added into the points array. So these are the 2 purposes. You can also refer to your tutorial videos. And the constructor over here simply would initialize the points array into some fixed size. So we're assuming that the point collector is going to store no more than 100 points. And here we didn't really explicitly initialize NOP over here, but I would recommend you actually do it. I didn't do it just because I don't have space over here in the slides. But you should you can say this.NOP is assigned to 0, even though it would be assigned the default value automatically. But it's good to be explicit about what you really want to do. So I would like to talk about these. So that's a constructor. One more time. One more point. So we got also this mutated method here, add points, and then I just give you sufficient information for you to create some local objects for the points, and then we can add it to the points array. So what I do is I say this the points over here, and then whatever counter value it is. Remember the NOP, the second purpose is to indicate where to store the new point objects. And then we simply assign that to this particular object address, right? You can see this might be something new to you. This is something called anonymous object, which I will speak a little bit more in detail later. But this one here simply means I'm going to create this particular object over here and then assign its address to this particular index of the array. And then I'm going to update by incrementing the counter over here, right? That's something you have seen already in the written notes and also in the tutorial video. Let me visualize what we have seen so far very quickly, okay? So here I try to put everything I have spoken about over here, right? You can see the points array, the NOP counter, and also the constructor initializing the points array, and also the add point mutator over here, right? Let's take a look very quickly. So let's say this is our point collector tester over here. Let's now see this. Let me say blue first. So after creating this particular point collector objects, right, it's actually going to call the constructor for the point collector. And for that one, it's going to initialize the point collector, it's going to initialize the points array. Right, you can see here we talk about PC. So PC is the context objects, right? So you can see PC over here, and the points array over here is going to be initialized to be an array starting from index 0 all the way to index 99. So that'll be size 100, right? That's pretty easy. And then we're going to call add points over here 4 times. Add point, add point, add point, and add point over here. So 4 times. The first time is going to be 3 and 4. And 3 and 4, for example, let's say if you got 3 and 4 over here, it's going to create this particular object accordingly. So 3 and 4. So that's why it's going to create 3 and 4 over here, this point objects. And the second time is going to be minus 3 and 4. Minus 3 and 4. And the third time is minus 3, minus 4. Minus 3, minus 4. And also 3 and minus 4, right? 3 and minus 4. I'm not really going sequentially. I'm just trying to show you the object structure, right? If you really want to see the detailed tracing, you can refer to your Java tutorial video week number 8, which I did in detail, all right? And then, so we're going to create this object here for every add points, and then we're going to assign that to the index. The index for, let's use purple. We're going to assign to the index of this.nop. Initially, NOP is simply just going to be 0, right? So the first time we actually call this, one here, we're going to assign this particular object's address to index 0, right? So that's why, because currently index the NOP is 0. So it's going to make sure we're going to point to this particular objects, right? After this, we're going to also increment NOP by 1. So that means it's going to it will go from 0 to actually 1. And then when we call this the second time, we're going to assign this to this.nop, right? It's going to be index 1. And then index 1 is now going to point to the second object over here, right? I'm just trying to skip some details over here because that's already covered. And for the third time, and of course, after this, we're also going to increment the value of NOP from 1 to 2, right? And now for the third object that we created, we're going to do that in index 2. Store the objects over here into index 2. So it's going to point to there, and then it's going to update the index NOP from 2 to 3 over here. And finally, the final call over here, we're going to have 3 and minus 4, right? This is the object we created, and then we're going to store that in index 3 over here. And then it's going to point to here, right? It's a very quick visualization about how this fragment of code is going to establish the object structure like this. So that's something I would just want to remind you quickly. To see the detailed tracing, you can refer to your week number 8 Java tutorial video, right? So for this one, I'm not going to repeat the details. All right, let's now see the most important accessor I would like to talk about, which is also in your written notes. But I think visualizing it together with you would be useful. So now let's go a little bit further. I'll just show you the slides very quickly just for you to get a big picture about how the code is going to work, and then we'll trace it in detail. All right, so we got this accessor method get points in quotient number 1. Basically, you can see we got all these points over here. We want to selectively return an array that contains points in the quotient 1 only, right? Remember, if this is your 2-dimensional point, that's quotient number 1, 2, 3, and also 4. 4 is like this, right? But anyway, so you can see quotients 1, 2, 3, and 4, right? And what will be in quotient number 1? That means x and y must be both positive, which means this will be the only point that will be kept in the return array, and the return array should be size 1, right? And all these should be bypassed because they are not really in quotient number 1. Okay, having the big idea, let's see this. So eventually we want to return the points array. However, the size of the points array return must correspond to the number of points that's in quotient number 1. We'll see. So initially we simply create a local PS points array that because the maximum number of points in the quotient number 1 can just be just how many points you have collected so far. You can see NOP, something you can see here. NOP, actually after the last one, I forgot to increment it to 4. So that means conceptually you can think about NOP is really NOP is really pointing to index 4. So this is where NOP is pointing to. So that means the next point you want to store, the 5th point, should be stored in over here. Should be here. But currently it's simply just null. Currently, right? And so far we have collected 4 points so far. So the maximum number of points that can be in the first quotient will be 4. That's a maximum, right? Theoretically. But it may turn out to be fewer than that. Well, in fact, it will just be 1, but we'll see. Okay, we just create this large array. Just try to be conservative, And then we're going to count how many points there will be in the first closure as we go through, right? So we're going to go through the array over here, and we spoke about why in the tutorial videos, why this part here should be this.nop rather than this.points.length, right? If you put that part as this.points.length, that means you're going to go over not only these slots over here, but also those slots over here that are simply just null. In that case, you might just run into null pointer exception. That's also something I discussed in the tutorial videos, right? I'll let you review that part. Okay, we're gonna say this.nop here, and then we're gonna say for every point we're looking at, we simply just create some local variable, pointing to points array index I. And then we're simply going to check whether it's really in the first quadrant, meaning that x and y must be both positive. If it is the case, we're going to use the count over here. I'll visualize that to you. The count over here is going to see how many points there are in the first quadrant, and we're going to use it to really count. Okay, we'll see that. Okay, and then we're going to also eventually, once we are done, we have to somehow convert the PS into another array for return. PS cannot be returned directly simply because in the case where, let's say for example, PS was initialized to be the maximum size that might be possible, but only one point has been selected. That means all the other 3 slots are simply just null for PS. So that means we should not return just PS. We want to somehow convert the PS, which will be something like this. It will be this first slot is really pointing to this particular object that's in the first quadrant, but all the others are simply just null. But we want to really convert this array over here into a single array, an array of a single index over here that's pointing to this particular objects. That's basically what we want to do, right? So for the last stage, for the method over here, we're simply just going to create just one more local variable over here, right? And then this variable here is going to be initialized to be the correct size, count. And by the way, count is guaranteed to be less than or equal to this.nop, right? So this.nop tells you how many points they have been collected. But the actual count may be 4 if all of them are in the first quadrant, or in this case it will be just 1, which is strictly less than 4, right? All right. After that, we're going to just go over the PS array over here by restricted by count. Count tells us exactly how many, and then we're simply just going to copy things over by reference, and then eventually we're going to return Q1 points. Okay. And then you can see the link about the PDF I spoke about. Again, you should really complete the reading carefully. If you got any trouble with understanding the textual explanation, ask me during the office hour or maybe the review session, the Q&A. Okay, so now the final part I would like to talk about for this example here, I would like to trace this accessor thoroughly together with you quickly. But with my high level explanation with the slides, hopefully now you got a big picture about what needs to be done. But let's now trace it in detail as well. Okay, so now we're assuming that we already got this particular runtime structure over here, which we visualized previously, right? They are the same structure. You can see, for example, NOP is currently 4. We got 1, 2, 3, 4 points collected, and we're going to we're going to create some local variable as well. But you can see conceptually we got 3, 4. So 3, 4. Let me do it again. 3, 4 here, minus 3, 4, and here, and etc. Only 1 point is going to be collected and returned as an array of size 1. That's something eventually we want to get. Let's now trace it line by line. Okay, so now let's start with line number 1. Over here, we say PS is going to be of size this.nop, right? So what's okay? Actually, you know what? Before I do that, let me just be clear about the context objects. So basically, we are trying to do this line over here, and this line is a continuation from what we did previously, right? Remember, we created PC, the point collector, and then we have already added in all the 4 points with PC as a context objects. So you can think about these 2 lines are exactly the continuation from this fragment of code. You will see that from the slides as well. Okay, let's do that. So what I want to start with is I want to trace this line. I want to start from tracing this line specifically, this line over here. Right, we're going to say PC.get points in quadrant 1 over here. And PC will be the context objects. So that means every occurrence of this is going to be replaced by PC, right? So let's now step into this particular method over here. So now we are tracing this method here, right? Get points in quotient 1. Get points in quotient 1. And this will just be PC. So this will be simply just PC. And also this will also be PC. And this will be PC. Okay, I think is there any other occurrence? Okay, I think that's it. Okay, good. Let's now trace line by line, step by stepping into this method. Let's now do it. So first of all, we got some local variable PS over here. And as we said before, it's going to be of the size PC.NOP, right? PC.NOP is simply just 4. So that means we're going to create PS to be of size this.NOP, which is 4. So now we got PS over here. Okay, my diagram here is actually not exactly correct. So what I will do is I'm going to redraw that. Okay. So PS over here is going to be of size 4. Maximum 4. So if that's maximum, that means all the 4 points collected so far are in the first quotient, but it's not the case for this particular example. So 0, 1, 2, and 3. All right, so that's this line here. Okay, so guys, this line is done. And then we're going to initialize the count value over here. So count will just be initialized to be 0. Okay, I'll put 0 over here. Okay, and then we're going to run this particular loop, which I will trace quickly. Okay, so this particular loop over here is going to do some updates about to really keep track of how many points are actually the first quotients. Let's now see how to do that. All right. Okay, and let's now do a little bit of prediction over here. How many iterations are we going to have? Well, since PC.NOP, the upper bound is actually 4. So that means 4 iterations. So I is going to be 0, 1, 2, 3, right? So now for that, let's say I is going to be 0, 1, 2, and 3, right? And then for every one of them, we are simply going to create a local variable P. And P is actually going to point to wherever PC that points at position I. And I will be either 0 or 1 or 2 or 3, right? So what's going to happen is you can think about, so PC dot points at some position I. So PC dot points, which refer to this array, it can be either this index or this or this or this, depending on which iteration you are at, right? Let's say for each iteration, let's go one by one. For iteration number 1, 0. So that means P is going to be assigned to this that points at position 0, right? So that means P, let me put it here. P is now going to point to wherever position 0 is pointing to, right? You can see here, P is pointing to wherever this array at position 0 is pointing to. That's P, right? So P is now referring to this particular object. That's aliasing. And then we're going to say P.x larger than 0 and P.y larger than 0. Is that the case? P.x, P.y, both larger than 0. Yes, it is actually correct. So what's going to happen is we're going to say ps.count. So what's ps.count? So count at the moment is actually 0. So that means ps0 is assigned to P, right? And ps at position 0 is not assigned to wherever P is pointing to, right? So now you should be very familiar with how to copy address around. So this position here is now going to point to this particular point over here, this point object here, for the first iteration. All right. It will turn out only the very first iteration is going to copy the points over to PS, because for all the other points, you can see they are not really positive for both X and Y. That's our prediction. But let's just go over a few iterations to see. Let's now see, let me use orange over here. For the second iteration, so now I is going to be 1, right? When I is equal to 1, we are still going to say P is now going to point to this that points at position 1. Okay, so this, which is PC that points at position 1, of course. PC that points and then at position 1 is pointing to this particular array. So you can think about now the P over here, rather than pointing to over here, is now going to point to this particular array, right? Hopefully you're following. And then we're going to do the same check. So P dot X larger than 0, P dot Y larger than 0. Is that the case? So now P dot X, okay, let me draw better. So P dot X and Y minus 3 for sure is going to is not larger than 0. So that's why this part here should be false. So that means we're gonna bypass. So it's going to be false, and then it's going to bypass this particular part. So we're not going to execute it for the second iteration, right? And counts will remain to be. Oh, actually, I forgot to do one thing. In the previous iteration, after we have assigned PS0 to this particular point, we should have updated count to be by incrementing it, right? I forgot to do it. So 0 to 1. Okay, that's for the first iteration. And for the second iteration, when I is equal to 1, and then we know that it's now P is now referring to this particular second object at index 1. That one there, minus 3, is not going to make sure it's not going to satisfy this condition here. So we're going to bypass this one here. So count will remain to be 1. All right. So now let me go a little bit faster here. And what about for index for loop counter 2 and 3? It's going to be the same, right? You can see for. Let me go a little bit more quickly. So now for when I is equal to 2, so that means P rather than pointing to over here is now going to point to this particular point objects at index 2, right? For the third iteration when I is equal to 2. And then you can see the X over here and Y here is not going to satisfy that, right? So it also is going to be false. And when it is false, we're not going to execute this line anymore. We are not going to. So that means count will remain to be 1. Finally, when we try to do the fourth iteration, similar. So now P, rather than pointing to over here, is now going to point to wherever index 3 is actually pointing to, right? Let me draw a little bit better. So now it's going to point to wherever index 3 is pointing to over here. And now you can see 3 and also minus 4. And minus 4 for sure is not going to be larger than 0. So that's going to be false. So again, we're going to bypass this particular part, right? And count remain to be 1. So that's basically this particular loop is really doing. So to recap, what we have done by executing this loop over here was PS has its index 0 corresponding to the count. Index 0 over here is really pointing to this particular point. That's really in the first quadrant. Conceptually, it's this point over here. All the other points have been bypassed, right? All the other points have been bypassed because here you can see minus, 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 and also minus. And the count being 1 over here tells us there is exactly 1 point that's in the first quadrant, and that's stored in the and then the count over here tells us all the points that's in the first quadrant has been stored in the indices up to but excluding 1. Okay, that's really important. In the case where count is equal to 3, that means all the points in the first quadrant have been stored in 0, 1, and 2, but not including 3. So the purpose of the count is very similar to the purpose for NOP. That's something you want to observe yourself. All right. Let's now finish off the tracing very quickly. So let's now go on to the next step. So now if I go to this outside the loop, I'm going to create another Q1 points array. And the size of that will be corresponding to the count, right? So that means I'm going to just create another array over here. So I would say Q1 points. It is going to point to an array of size 1, right? You can see count is actually 1 over here. And then we are going to just run the following loop. Let me circle that. So this particular loop over here is going to be very important. You can see for this particular loop, we're actually going to go. You can see it will only go up to but excluding the count, right? You can see the count over here. Currently, it is 1. So count. Let me just say a little bit more. So count over here tells us there are basically count minus 1 points. Oh, let me say a little bit better. There are two items over here you should really notice. There are count points in Trojan number 1, and number 2, these points are stored in indices 0 all the way to count minus 1. Okay, let me just use this example to show to you. There are count points in the first Trojans over here. So how do we see this point? You can see count is equal to 1. So that means there's only 1 point that's in the first Trojan, only 1. So point number 2, we say that these points are stored in 0 all the way to count minus 1. You can see 0 all the way to count minus 1. Count in this case 1 minus 1 will be 0, so it's only this point. So it's not really stored in index 1, not index 2, not index 3 either. Alright? So that's about how to interpret this particular count variable. It's really important, right? And then we're simply going to run the loop. How many iterations are we going to run? Only 1 iteration, right? And then inside this iteration over here, I'm going to write it down. Inside this particular iteration is going to be Q1 points at position 0 is assigned to PS at position 0. So we're basically copying the address of PS0. So you can see PS at position 0 is pointing to this particular object. Copy this address over to Q1 points 0. Q1 points is really referring to this array. Copy the address into this slot. That means it's going to point to just the same objects, right? So we have done aliasing also examples from last week as well about the Alan, Tom, and Mark array example. So this one here is going to make sure this Q1 points at position 0 is now going to point to this particular points. So this is really the final outcome we have over here. You can see Q1 points is really pointing to an array of size 1, and then that is going to that one is pointing to this particular points, the only point that's in the first Trojans, right? And then eventually we're going to return the Q1 points. So what we are returning is the address of this particular object, just the address. And then Q1 points is going to be stored into PS, right? You can think about this particular part. The return value from the method call is simply just Q1 points. Okay, and then we're going to store that into PS. So you can think about PS is simply just another aliasing that's going to point to wherever Q1 point is pointing to. So now let's have PS. Let me use maybe this color here. You can think about PS is just the ultimate. Well, notice one thing here. The PS over here is definitely different from the PS over here. The PS over here is under the context of the console application main method that we are doing. And this PS over here is under the context of this particular get points in Trojan 1 method, right? So if you really like, I can disambiguate this a little bit. You can think about this PS over here is under the get points in Trojan 1 method, right? It's in a different scope. But this PS over here is under the scope of the main method. Just don't get confused, all right? So it's better for me to maybe use a different color over here just to make sure you know they are different. Even though they have the same name, but Java compiler will be able to tell the difference in the scopes. All right, so PS is now really going to point to wherever Q1 points is really pointing to. So it's just going to point to the starting address of this particular array, right? So that's really the thing to be returned. Okay, over here. All right, and then eventually going to return. Oh, sorry, not here. And then let's now do some printout. What would be PS.length? PS is pointing to this particular array. What's its length? Well, just 1, apparently, right? Just pointing to this single point that's in the first Trojans. So this part here will just be 1. And what about the next one? The next one will be, what will be, let me just write down the expression over here. So we actually got ps0.getx and also ps0.getY. Okay, let me write it down. So we got ps at position 0.getx. Let's just use this one as an example. So this is more like the use of the dot notation. You can think about this part over here is the context objects, right? Context objects, and we are calling getX on this particular context objects. Let's understand what ps0 is. PS is pointing to this particular array, and then at index 0 is pointing to this particular point objects, right? And then when we say getX, we're really calling getX on this point objects, right? And similarly, when you say ps0, ps referring to this array, at position 0 referring to this object over here, get y. You want to call get y on this particular object. Similarly, right? So what will be the value? Get x should really get the x for this particular object, so that will be 3, and get y will be simply 4 over here. Right? If you tried it out on the console application, you will be able to see the output. But I will also encourage you to try to really turn this console application into the JUnit tests as well. All right, guys. It's really a thorough tracing over here, but the written version of my illustration over here is also in the written notes. But I think if you try to study both together, you will be able to gain hopefully the most thorough understanding. All right, so that's about the end of this expression, this programming pattern here. It's really important for you to know how to manipulate when you got array and also the array of reference types and also its counter, how they work together. And I think this particular get points in Trojan 1 is a very nice example for you to see many important artifacts. You can see local arrays. We have created actually several local arrays, and then eventually you want to return just a single reference over here, right? You can see the return type is simply an array. And also you want to use different loops over here to really selectively choose the object to be stored in the array. All right, study this example carefully, and then we'll move on to the next topic.